really briefly. Uh-oh.
I just started recording.
Okay. Sorry, Susan, I forgot to wait for you. Remind me.
Here we are.
All right. So we're recording now.
Yes.
All right. And so I'm going to put in the chat the location of this repository, which is where we'll put all of our talks. And we've tried to prepare talks for you that have working examples in them that you can take back and start using. And so Suba did the overview, and for today we're going to focus on interactive computing and then work into Jupyter Notebooks. So Manu will talk about how to set up the environment because it needs to be done properly, and Scott will talk about security, and Marty will talk about our Galileo client that you can use to launch secure notebooks, and then we'll do the hands-on. So with that, I'll try and go into screen share. Does that look like my presenter view or the wrong view? Can you guys?
View? Sure.
It's
That's
the proper view.
Yes.
Okay, so I'm Mary Thomas. I'm the HPC training lead at SDSC, and I have a background in physics and computational science, and I love high performance computing. And so today I'm going to do a very quick overview of interactive computing and what that means in the world of high performance computing, and then how to run the jobs, different kinds of interactive jobs, and give you a couple of examples that you can work with. Okay, there's some links that are in this talk for you to go and look at later, and I'll reiterate them at the bottom at the end of my talk. So what's interactive computing? You do it all, you're all doing interactive computing right now. You're working on software and using and interacting with software on your laptop, and it's just local computing, but it's still interactive computing from a computer science perspective and design standpoint. Interactive high performance computing involves real-time access to those nodes. You're all really familiar with writing a batch script and submitting that to the queue, waiting for the queue to find some nodes for you, and then get the job run, and then you find out it's done and you get some data. And that's good when you need to run in that mode. But more and more there's applications that are more interactive, like Jupyter Notebooks is a big driving point, Matlab, R, and other application visualization, ParaView. So interactive computing to us is when you get that compute node all to yourself and you can interact with your code, you can run an application or interact with your data. And so these are some of the common scenarios. There's Jupyter Notebooks, which many people are becoming more and more familiar with. And I think it's really popular because you're right inside the code. And when you make changes, you can see changes immediately. It's got a really good feedback system. There's Matlab, Parallel, which is a mathematically oriented programming environment. And then there's distributed computing using Jupyter technologies involving Jupyter services. And then a commonly known HPC visualization tool is ParaView. So you would want to launch ParaView on one or more nodes and then interact with it somehow on your local host. And those are just a couple of the scenarios that are evolving, and they usually involve big data in the back end and large resources, like even one node with a lot of memory, for example. So you have to run interactive jobs on compute nodes. We don't want you, and they won't be allowed to run on the login node. There's just not enough memory, and people get on the login node to get work done. They don't want you using up their compile resources running your lovely Jupyter notebook. So we're trying to facilitate that. And the Stratus project was an experiment in trying to figure out how to do that for Jupyter technologies and other interactive technologies. So once you get your system set up, it's pretty straightforward, but you have to remember, get a compute node and then you own it. You'll own most of it or all of it, depending on what you ask for, and you can run on an HPC node. So you have to submit a request through the queuing system so that the scheduler can find a node that's available for what you need. And this is, you have to figure out which queue you want. There's many queues. There's the hotel queues, GPU, CPU, there's large memory, there's whatever your home group queue is, the condo queue, the GPU, and the Glean queue. And they're all very, very busy, as you can tell, but you can get an interactive node and then start running your jobs. So the way you do that is it's a very straightforward command that's showed here is qsub, and you use -I for interactive, capital I, -L, the number of nodes that you want, and you can add the wall time, it's not required. And this is the simplest version of qsub, and of course you could be adding other requirements to it. And so all the jobs have to be submitted via torque, or they're not going to get allocated. And then there are batch jobs, which you already know. So we're going to take just a moment to step back and remind you of some of the basics for running HPC jobs, that you're submitting jobs to the torque queuing system. And you're used to using the batch jobs. And now there's the new way, which is with interactive jobs. And so this one, when it's done, you'll wait for the job, you'll sit there and watch it and wait. And depending on how busy the queuing system is, you might wait a minute, you might wait 10. It depends on the queue, the partition you ask for as well. So you just run this command, and then here we're specifying the condo and an account. Also, there's commands, some useful commands, the PBS-KOE. This will force the standard error and the standard out to go to one file or one directory, depending on how you set it up. And then QAlter will allow you to change some of the parameters of your job. And QDelete, you can delete the job. And that can happen like you decide to wait for an interactive queue, and then you decide, I don't want it, delete the request, because otherwise that queue will, the queuing system will allocate your job, and you've gone off and you're using up some CPU time. So the other thing you want to do is monitor your job using QStat, and you can look for all of your jobs, or go by a job number, or see everybody in the queue. And then YQD prints out why the job hasn't started. This is a really nice tool. And then you can list jobs to see what's on, how available is a node. Again, you should all be familiar with these, but we included them just to kind of remind you, and you can check on your job and get more information about what the job is doing. And you can show the queue and show start and get more information. There's a misalignment here, apologies for that. You can also, you need to know your account for submitting a batch script. So you have to know what group are you in, and then you want to know which group you want to charge your job to. And then you can find out the balances that you might have in that, and get the job, the account number, which you have to put into the batch script. And so you can check your usage. So what I'll do now is very quickly go through some, how are we doing on time? Some examples. First of all, one reason you might want to have an interactive job is to run these applications. And I'll show you some examples for that, but just to test out your MPI code. And so you can get a node just like normal, and then you can compile your code, and then you can use MPI run from the command line. So you can do a really small or larger command and run your parallel code and get an idea, is it really working? And that's a really nice feature of the interactive node, if your job can fit on the node and run. So that's just one of the simplest ways of using an interactive node. And then you can go up from that to running something like Matlab. And again, same kind of command syntax. It isn't changing very much. And when you get here's an example where it shows my request for the node. I have to wait, I get a job ID, and then a few minutes later, the job ID is ready. And it can sometimes take a minute or two once you see the ready. And then you'll know you're on an interactive node when your login prompt changes. So here I'm on the login node, and now here I'm on a interactive node, the TSCC-13-12. You can actually log in. You own it, you have access to it. So it's yours for the 30 minutes or 2 hours or whatever you asked for. And here I'm going to load the Matlab module. And then I'm going to say Matlab, and then up will come a Matlab Interactive. The no display means don't show me the GUI. There's two ways to run Matlab. This Matlab no display will get you the regular Matlab command line version. Okay, so that's this example. Now, if you want to run Matlab with the GUI, you can do it. And it's going to, the performance of it will depend on your network connection, but you certainly can. But you have to enable X11 forwarding. And that's done differently depending on whether you're on a Mac or a PC. So I've included in my talk a simple page where they do a summary of X11 forwarding. And you can look at it if you're running on a PC. But for a Mac, for example, you want to set the X11 forwarding on the system. And the way it's done on Mac is with an application called Xquartz. And I found that I had it installed, but I did a reinstall. So I used Brew. You can install it in many ways, but I did an update this week and discovered that it had changed. So that make sure you keep it updated. So I got it installed, and then the next thing you do is you log on to TSCC using the -y. This is an authenticated, a variable that will have authenticated X11 forwarding. What that means is when you do X11 forwarding, I forgot, maybe you might not know, that means you'll be able to go onto another system and have whatever GUI is being produced on that system show up on your laptop. But you have to get permissions through all the different systems. So we have to enable it on the laptop, enable it going through the login node, and then enable it going onto and coming back from the interactive node. So we have to have permission, and you're the one who sets all that up, given the way the sysadmin people have set up the systems, and Scott will be talking about security. So I do my SSH onto the login node, then I get my interactive node. Once I get on the interactive node, what I did here is I used -I for interactive and -X for X11 forwarding. Because I'm internal to the system, I don't need -Y, so we use -X. And everything else is the same. So you add this -X, I'm waiting for my node. I've got my interactive node. There's no visual GUI at the moment. What I have to do, in this case, I'm going to load the Matlab module and then run Matlab, and you'll see this printed out. And then it might take a minute or two to get everything set up, but when it's done, you'll have Matlab. And just to show you that it worked, I did a little matrix multiplication example. So the hardest thing is making sure, if you're on Mac, that your laptop is proxying the X11 properly. So if you have trouble, reach out to get some help from the support people to make sure. PC people, I understand it's a little more straightforward. Now you can also run R, the R console. And here's just a simple example. Again, this looks very familiar at this point. You can see you might just want to save that in a text file so you remember what you like. And then we've got our interactive node, and then we load the R module. And then I run R, and I end up inside the console environment and just do a simple example. Finally, one of the most interesting interactive job types is Jupyter Notebooks. And many of you have worked with it. It's this open source interactive notebook environment, and it has different services, Notebooks, Lab, and then Jupyter Hub. But it's got a key vulnerability, and Scott will talk about it and Marty will talk about it. We've spent almost the last year and a half or two examining it and coming up with a solution that allows you to host a secure notebook. By default, it's HTTP. And as Scott will tell you, that's a bad thing. That's a vulnerable system. And there's some other aspects to it that they can talk about. So we have a solution called the Satellite Reverse Proxy Service, and Marty will talk about the client for accessing that so you can have a secure notebook. So hold on, we'll get to the fun stuff in just a moment. Okay, so some resources are also in here from our help support, and then links to associated material. Thank you for your time. Any questions?
Yeah, I have a quick question.
Sure.
Is it possible to actually run RStudio on the on TSCC?
It's not from a Mac, the X-Quartz, yes, you can with a PC, but the Mac X-Quartz does not at this moment support RStudio.
Okay,
It's
thank you.
really unfortunate.
Yeah.
Yeah, sorry about that. I think that Suba and her support team have been trying for a long time to make it work, and we gave it a good go, and it's just X-Quartz does not allow it.
Yeah, I just want to jump in and just say,
Yeah,
if you have like a
Suba.
virtual machine, you can. If you have like a virtual machine, you can run the RStudio.
Oh,
So if you're running a virtual machine on your Mac laptop, then you can run RStudio.
Yeah.
Okay. Good question. Looks like people have answered the other questions. So with that, we're staying on time. So I guess